questions. As I look at number 17. Number 17, you had 4 to the third divided by 4 to the second. Rule says that if we are dividing, we should subtract our exponents, which just leaves us with 4. Okay? If I'm looking at number 18, if you have not done this, please make sure you do this one with us, or with me. Easiest way to do this is to simplify inside this parentheses. So we're going to keep this -2 outside here. And this line means what's happening with 8 and 4. What is that line telling us to do? Divide. So 8 divided by 4 is 2. Now we just said that when we work with our exponents and we're dividing, we have to subtract their base, or subtract their exponents. So we have x, and we should be taking 9 minus 7. So we really have 2x to the second raised to the -2 power. Okay? So if I'm looking at that, 2x to the second raised to the -2. -2 always tells us to take the reciprocal. So I write that as 1 over. It is 2x to the second power in your workbook on page 12. So you guys are just going to write that in. Okay? So if we are looking at this, we took the 9 minus 7. That gave us the second power. We now have this answer. This isn't simplified because we still have this parenthesis. So if I am looking at this, I am now going to take 2 to the second power. And x, I'm going to take the 2 times 2, which leaves me an answer of 1 over 4. That should have been 2 to the second right there. And x to the fourth. And I'm going to show you the answers in just a minute for these. The other question was on number 3. When you take a look at number 3, there is nothing outside of these parentheses, so the parentheses simply mean multiplication. When we multiply, that means you are adding the exponent. So we should have had 2 plus 3 for our exponents of x. We have y to the -2 plus 2. We should have had x to the 5th, y to the 0, -2 plus 2 is 0, and our answer is x to the 5th. I'm going to show you the answers so that you can correct yours, for those of you that did it. The answers for B were in the back, but here are the answers for C. So make sure you take a look at those. Check yours. Okay. I think is your notes. So please go to C7 in your notes. You can keep your workbook open just right behind your notes on the same page. And as we are looking at this, we are going to be looking at scientific notation. Now, some of you have used this before, some of you have not. I want you right now to just multiply all of those things, 9.2 by 10, 100, and 1,000. Please do that and write it right in your workbook or right in your notes. So 9.2 times 10, how many places would I move my decimal point? That's going to give me 92, right? So this is in your notes. Did I give you a notes one? Okay. Do the next one. Write it down. Do the next one. If you multiply by 100, what should you have? We should have 920. Keep going. Multiply by 1,000. We should have 9,200. Thank you. This next problem down, what we want to do is we want to divide by 10. Now, when we multiply by 10, 100, and 1,000, what do you think the shortcut is? I don't really want to actually multiply these out. What is our shortcut? Someone want to raise their hand? What is our shortcut for multiplying by 10 or 100 or 1,000? What did I actually do with my decimal point, Daniel?
You moved it over the number of zeros.
So the shortcut for multiply by a multiple of 10, if we are looking at that, the shortcut is to move the decimal. So multiplying by a power of 10, we move the decimal to the right, the number of what? The number of zeros. So kind of thinking about that as we now do division by 10. Our decimal, if it's not written, is always right behind a number, right? So if there's no decimal in that problem, it is right behind the very last digit. So if I'm dividing by 10, this should be 873. Here I'm dividing by 100. That means I'm going to have 87.3. And now we're going to divide by 1,000. 8.73. Now usually we don't put the zeros behind, and I will not have you write those zeros behind also. We're going to leave it like that. So we just said the shortcut for multiplying by powers of 10 or multiples of 10 was simply to move the decimal to the right. So now please write dividing so that we make sure, because that was our shortcut. So this is our shortcut for dividing by multiples of 10. And that is, this time we're going to move the decimal to the left. And how are we moving it? How do we decide how many places to the left? By the number of zeros again. By counting the number of zeros. Okay? So we want to continue that as we look at that next page down in your notes. Okay? And when you look at that, I want you to fill in that first column and start with the 10 to the 0, the very last one. Okay? So 10 to the 0, some of you missed this on the quiz. It was so unfortunate to mark 2 wrong on something like this because you thought this answer was 0 when it should be
1.
1. It was very unfortunate. 1. 10 to the first? 10. Please do the next ones filling those in. Okay? And you can check with your shoulder partner. We should not, this is not 10 times 2, right? This is not 20. This means 10 times 10, right? So I should have 100. 10 to the third
1,000.
is a 1 followed by 3 zeros. So this number should be telling us the number of zeros behind 1. So 10 to the fourth should have 4 zeros. Okay? Now, first we're going to write these as decimals. Actually, we're going to write them as our fraction. Because what if we say 10 to the negative 1? So I want you to put the first ones as fraction. And then right below it, we're going to write the decimal value. Okay? 10 to the negative 1 really means 1 over 10 to the first. So 1/10. Well, we just saw that 10 to the second was 100. So 10 to the negative 2, if I'm going to write that, should be, Ellie, 1 over 100. 10 to the negative 3, if I am looking at that one, Bo, should be 1 over 1,000. So I know my 10 to the third is 1,000, 1 over 10 to the third. When I'm looking at 10 to the negative 4, I should have 1 over 10,000. What do those decimals look like? So right now we want to put the decimal equivalent to those. So I should have, Brett, 1/10 being 0.1. Chloe, if I'm looking at 100th, I should have 0. What is my decimal equivalent to 1 over 100? 0.01. So tenths, hundredths place, right? The next one is going to be 0. And if I'm looking at that one, Sophie, I should have? Yes. And then my last one, Peter, is going to be 0. I'm going to have the 3 and a 1. I want you to notice that the 1 is in 4 places back. Here, the 1 is 3 places back. There's 2 zeros. The most common mistake is writing these is that people think this means I should have 3 zeros in front of the 1. it does not mean that. It means the place value has to come out in the thousands. So you got to be careful for that when you are looking at those, okay? This is going to be really important when we get into our scientific notation. So it says different ways of writing numbers. For example, you've probably seen Roman numerals. Today we're going to look at other forms. So we're going to talk about decimal notation, product form, and scientific notation. Decimal form, that's usually how you write your numbers. Usually how you write your numbers, okay? So this is usually how you write numbers. Like 720 would be 720. Like 0.15, you'd write it like this. That is our standard form of writing a number. It's just how we usually write our numbers out, okay? Product form. Product form means we want the first number that we are going to take usually to be between 1 and 10, okay? So this number that we're going to write here has to be between 1 to 10, okay? And then we're going to take it times 10 or 100 or 1,000, or we're going to take it times 0.01, okay? So all of these different numbers, or it might be times 0.001, that's what a number would look like in product form. So 720, okay? If we're taking this number, what does it look like in product form? In product form, it would be 7.2 times 100. Does that make sense, everyone? 720, 7.2 times 100. I moved the decimal over 2 places, so I put 2 zeros back here. If I am writing 0.15 in product form, it would be 1.5 times, how many places am I trying to move my decimal? 1 place to the left, so this is going to be times 10, but it's not going to be 10, it's going to be 0.1, right? Because we're really moving that 0.1. Remember, if we think about this last part when we were doing this, right here, multiplying by 1/10 or by 0.1 when we are looking at here, dividing by 10, that's the same as multiplying by 10 to the negative 1. This is the same as multiplying by 10 to the negative 2, dividing by 100. This is the same as multiplying by 10 to the negative 3, okay? So put this in that first page of notes right up above there. This is the same as, dividing by 10 is the same as multiplying by 10 to the negative 1. Multiplying by 10 to the negative 2. Multiplying by 10 to the negative 3. Make sure you have that. Don't have your worksheet or work on that now, please. Okay? So, what we want to take a look at is scientific notation. And this is mostly what we're going to be working on. So, scientific notation is we are going to, again, have a number. This first number has to, again, be between 1 and 10. It's going to be times 10, and then you're going to have a power or an exponent. This exponent will either be positive, or this exponent will be negative. How do we decide if it's going to be positive or negative? When the number in standard form, so if I think of in standard form, so when I think of the numbers up here in standard form or decimal notation, it's going to be positive if that number is greater than 1. So please write positive exponent if it's greater than 1. When will this be a negative exponent? When the number in standard form is between 0 and 1, meaning it's a decimal. So if, like this one, being a decimal, I know I have to have a negative exponent when I do that one. 720, if I'm writing in scientific notation, is going to have a positive exponent. So what is 720? Let's write that right below here. 720 will be rewritten as 7.2. So today one of the worksheets you're going to do is on the daily planner. You're going to put down like the 720 on your notebook paper or on your paper. You'll put equal and you'll tell me what it's equal to. And you'll go 7.2 times 10, and we are going to be moving our decimal over 2 places, so I'd have times 10 to the second. You would, on that same worksheet that's attached to the daily planner, the page 68, put down the 0.15, and you tell me, oh, in scientific notation, it's going to be 1.5 times 10. Well, how many places do I have to move this decimal to get it to be 0.15? I have to move it 1 place, so this will be times 10 to the negative 1. So as we are looking at these, you're going to be switching back and forth, okay? So, what's that? Okay. All right, so we want to now put these numbers in our product form, scientific notation, and decimal notation. Remember, decimal is really sometimes referred to as standard form, okay? So if you see standard form or decimal notation, those mean the same thing. They did the first one for us. 45,000, 4.5 times 10,000, 4.5 times 10 to the 4. 240, 2.4 times 100. We are going to rewrite this over here as 2.4 times 10 to the, how many zeros? Second. Also, the other way to think about this is that you move this decimal right here back 2 places, okay? So let's go right away from this one. We're going to start in our product form. We know that we have to get the decimal over here. So this first number always has to be between 1 and 10. So between 1 to 10 times a power of 10, or times a multiple of 10. So I'm going to have 8.5. And I would be multiplying thing times what? To get 8,500. Okay, so if I only multiply 100, I only end up with 850. Should multiply it by 1,000. Does that make sense? So if I'm writing that over here in scientific notation, 8.5 times 10 to the, how many places? To the third. Okay, so this one, let's go right to scientific notation. 3,400,000. We're going to write it in scientific notation. It really means 3.4. And then as I'm looking at that, how many places do I have to move it as I am counting, Lizzie? How many places do I have to move that 0 over to get between the 3 and the 4? So this is 3. Yeah, and it's easier to do it like on your own paper and actually do each one of these. So times 10 to the, I want to get between the 3 and 4. 6. So there's 5 zeros, it's times 10 to the 6, right? If I'm looking at this one, I want to write it in scientific notation. I'm going to keep the 5.1 times Zach. If I'm looking at 10,000, that means 10 to the what power? 10 to the 4th. I now want to change this to scientific notation. Haley, when I think of this 5.1, how many places do I need to move that decimal over? 4. I need to move it 4 places. So this is what we started with. We started with 5.1. You cannot, when you write this number, keep this decimal in here, okay? But we want to move it 1, 2, 3, 4 places. That means I'm going to have, if I'm looking at this number, 51,000. Now, when you're done with the problem, you probably want to erase those in your homework, but you want to make sure that you do not keep this decimal. If you keep this decimal and you have 5.1 and then you have this parenthesis with all of these, I'm going to mark that wrong. You can have these little loops, I call them, to help you to show where you got your answer, but you do not want this decimal in here. So we got 7.25 times 1,000. Right, so I'm going to write that as 7.25 times 10 to what power?
To the third?
10 to the third, because we have 3 zeros following the 1,000. Following the 1 in 1,000. So we're going to have 10 to the third. We now want to write it in scientific notation. If I'm writing it in scientific notation, Layla, what am I going to end up with?
7,250.
7,000. Oh, thanks for reminding me. I forgot the 5 here. 725. Good job. And then you said 72,500 or just 7,000? 7,250. And if you think about that, we moved it 1, 2, 3 places. So 7,250. 1.5 times 10 to the third. If you haven't already, I would like you to write that right now in scientific notation. Okay? Write those both in scientific notation. If you haven't done that, please do that right now. The first one, I should have, Brett, what?
1,500.
Should have 1,500. If I'm looking at that last one, 3.6 times 10 to the second, I should have an answer of what, Brayden?
Yeah, I don't know this one.
How many places do I need to move this decimal over?
2.
2. So, what you gonna get? 3.6, move it over 2 places?
360.
There you go, 360. Okay? Make sure you have those down on your paper. Now we're gonna do the ones, and this time we're gonna do it, and we are looking at our problems being in, when we look at the problems, we are looking at them being our decimal form. And here's the most confusing thing. Here's what we want to do. We are counting 1, 2, 3 places. So 7.5 times 10 to the negative 3. Here we are counting 1, 2, 3, 4 places. So when I write that, I'm going to have 5 times 10. This is a small number, so it has to be a negative exponent. As I'm looking at the next one, the first number, what do I want to write that as, Kayla? It's this whole thing, 7, 8. What is my first number? It has to be between 1 and 10. Okay, so I'm going to have 7.8, right? I have to have the decimal, I have to have the number following. So I have 7.8 times 10 is going to be a negative exponent. As I'm looking at that negative exponent, I need to count how many places I'm moving it. So Kiona, I'm moving it how many? So I'm going to have times 10 to the negative 5. Daniel, if I'm looking at this one, I have 2.9 times this decimal. I'm going to rewrite that here as 2.9 times 10. How many places am I moving my decimal point when I multiply that? Negative. So when we are looking at this one and we had 1, 2, 3, 4 places behind, we had negative 4. If we're looking up here, we have 1, 2, 3, negative 3. What should my exponent be?
Negative 4.
Negative 4. There. So let's write the 5.2. If we are looking at that 5.2, and I'm looking at that one, Avery, what are you going to have? 0.52 changes to 5.2. Negative 1. So we're looking at this one now. So this is what you're going to write down in your homework today. You'll put this problem down, and then you're going to be asked to change it to scientific notation, or to standard notation. If I'm thinking of this number, I'm going to start with my 2, 9, and then I am moving my decimal 1, 2, 3, 4 places. How many zeros are going to be in front of the 2, 9? 3 or 4? Behind the decimal point, 3. If you always want to think of this one, I had someone in one of my classes one year tell me, well, if you put the 0 in front for the placeholder, then it's always the same number. If not, it's always 1 less. So if I'm looking at this next one in scientific notation, 3.87 times 10, how many numbers are behind my decimal point? This is going to be negative 3. Okay? So Braden, we're moving this one. 387. I need you to focus up here.
Okay.
So we are moving it 1, 2, 3 places. That's my decimal point. I add this 0. That makes it 4 zeros. 1, 2, 3 zeros. Excuse me, 3, not 4. This is a -3. I have 2 zeros behind the decimal point. This makes it a total of 3. Which means if I'm looking at this 2.6 times 10 to the -4, please try these next two and check with your shoulder partner. And we're going to put those up. Try those next two. Check with your shoulder partner once you do it. So check with these guys behind you, okay? I want the scientific notation part, or the standard form part. So you're going to have the 0 point. And if it helps you to look at the ones above, make sure you're doing that. All right, what'd you have for the 2.6 one? Want to tell me how many zeros I should put behind the decimal point?
3.
Should have 3 zeros behind because I have a total of 4 zeros. And then I'm going to have 2 6. Okay? Peter, how about this one? How many zeros before 4 9? 1 and then 4 9. Right? Okay? So make sure that that is making sense to you. Now, I'm going to put this video online so that you can watch this and you can hear it again for those of you that aren't getting this. And if you even do a Google search of scientific notation on YouTube and you're not understanding this, this would probably be key to helping you. So what is the pattern in problem 4? So that's the first one that we did. The pattern is this that we are looking at. When you change from standard form, and you don't have to write every single part of this down. When you change from standard form, you're going to move the decimal to the left to get a number between 1 and 10, right? That's the first thing we did. When we started standard form, we moved the decimal to the left to get a number between 1 and 10. Every exponent was a positive exponent, and it tells you the number of places you moved. Okay? That is key. It tells you exactly how far you had to move the decimal. Okay?
Alright, so center form move decimal to the left to get a number between 1 and 10.
To get a number between 1 and 10. Positive exponents because it was a number greater than 1, right? All the ones in that first one were numbers greater than 1. Okay? That's here, right? These were all numbers bigger than 1. So when we looked at those from that first column in decimal notation, what did we do? We moved it to the left, 1 to 10, positive exponent, the number of places we moved. Okay? What did we do on that next part with the decimal part, with a number between 0? Okay, so this is when our number was greater than 1. This is when our number was between 1 and 0, when we had decimals, right? When we had a decimal, what did we have to do? Same thing. You're going to, sorry about that. You're going to move the decimal, only this time you're moving it to the right till you get a number between 1 and 10. Okay? So if we think of the standard form, that very first column, that decimal form, we still have to get a number between 1 and 10. This time, negative exponent, and it tells us how far you moved the decimal. So it's always how far you move the decimal, not how many zeros, right? How far you move the decimal, and that's probably the most confusing thing for students when they start doing scientific notation. They want to count and always put that many zeros behind when it's written in scientific notation. Which it only works if you have like 5 times 10 to the third. Then you do put 3 zeros behind. But anytime you have that decimal, it's not going to work. Okay? So, this is the worksheet in your workbook. Okay? This is the worksheet that is on the daily planner. Okay? So, I want to look at the one in your workbook first, and then I just want you to know that that one that's on the daily planner, you have today and tomorrow to do that, okay? It's the page 68 on the daily planner. You can do it tonight, you can do it tomorrow night. That worksheet is actually going to be due on Wednesday's class, okay? This one should be due for tomorrow. What does it ask you for the directions in the first one? Classify it as greater than 1 or less than 1. Does that mean I want you to rewrite it? No. I want you to look at these exponents right back here. And you should be able to classify by if it's positive or negative as being greater than 1 or less than 1. Someone said, can I use an inequality? Like, can I put greater than 1? Or can I put less than 1? Or could I just write the word greater or just write the word less? Yes, I would take any of those. Okay? Here, we're writing it in scientific notation. So, if we are looking at 7 through 12, anyone want to pick one that we could look at? 7 to 12, you have to write in scientific. Or are you guys okay with those? Because I do one. Which one? 11. So 11 is really small, which means my exponent has to be, when I do the times 10 to a power, it has to be negative, right? I need a number between 1 and 10. What's my number between 1 and 10? Where do I have to place that decimal point? Between the 5 and the 2. 5.2 times 10, it's going to be negative. And now count how many places. And to me, sometimes the easiest way is to just take, you go 1, 2, 3, 4, 5, 6 places. Negative 6. Answers are in the back for you to check, so make sure you're checking them. Okay? So 5.2 times 10 to the negative 6. Down here, you're writing them out in standard form. Okay? Use your notes if you need to. If you finish this on the daily planner, what you are going to do, and if you know there's no way, like you have internet access at home or you don't have a study call, there's no way that you are going to get to this worksheet. I have a few copies, but it's today and tomorrow. So if you have advisory tomorrow, you could do an advisory, right? If you're here. It asks you to choose a number that's written in scientific notation. So behind number 1, you would write the one that is in scientific notation. And then you would put that down. So if we're looking at that, which one looks to be in scientific notation? The first, second, or third?
No.
Is this a number between 1 and 10?
No.
Is this one? Yes. And this one is not. So what I would put down on my paper is I put the number 1 and I put all of this on my paper. Okay? Number 2, then I choose the 1. Okay? When I get to number 3, I'm going to put this problem down times 7.2, and then you have to tell me the answer up here. Does that make sense? So you're going to say, oh, I had to move it 3, 6. So here n is 7. So you're going to write this down, this, and instead of putting n here, you're just going to put a 7, that answer. Does that make sense? That's how you're going to do this. So if you finish this first one, which actually goes pretty quick for most people, get on the daily planner. It is attached. While you are looking at that, I want you to look at, I also put, so this is the worksheet. You click here. It comes up as your worksheet. There's another one attached. We're not doing that one, right? It scanned both of them when I did that. While you are working right now, I am going to put on one of my videos that I attached from a few years back. Scientific notation song. Some of you don't go to the daily planner ever. You don't look at the videos that I attach. You don't look at some of those things. And then you say, you know, Mrs. Thompson, I'm just not getting this. And how could I go back and go over your notes and look at this? So, while you're working.
I have a question. Wait, I was going to say, Thompson, your phone was ringing.
That's okay.
Some numbers are really big. Some numbers are really
I gotta plug in my
small.
microphone
I
for
wish
you.
there was a way to easily express them all. We have found there's an easy way.
We have found there's an easy way to show extreme scientifically.
You can work on your worksheet while this is going.
Notation does it easily.
And
Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 300 in scientific notation is 3 times 10 to the power of 2. 10 to the power of 2 is 100 times 3, that's 300, so as you prove, scientific notation uses exponents, but with the base of 10, so you don't have to write out so many zeros again, and again, and again. Take a number like 0.0023, plug it in the 8 times 10 raised to the power of b, where a equals 2.3 and b is negative 3. You get 2.3 times 10 raised to the power of negative 3. Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 0.03 in scientific notation is 3 times 10 to the negative 2. 10 to the negative 2 is 0.01 times 3, that's 0.03, so yeah, well, there's your proof. Express your number so that it's more than 1, but less than 10. Take that number and
So, some of you sometimes will look at those and some of you will not. And the key thing that I just want you to be aware of is that there are many more resources out there and you gotta make sure that you're checking those as you are looking.
Wait, can you play that again?
So, it is on the daily planner and at any point in time, you can go there and click on that. And we got 3 minutes as I'm helping you with your worksheet.
Wait, so you were recording all of that?